Whoa, welcome to lesson 4.5, proofs with parallel lines. Now, I'm going to say this. We're going back to your favorite topic, that's proofs, which you learned about in level 2, congruent triangles. Remember those guys? You loved them. You're like, I can't wait to do more proofs. Well, guess what? Today's your day because we're doing more proofs. Now, today we're going to be using what we know about parallel lines to help us with our proofs. So these theorems that you see right here, 1, 2, 3, and 4, not going to read them to you, will be very helpful. All right, so let's just get into it. We got some proofs to do. Number 1, all right, chickity check it. What we're trying to do here is prove that triangle MON is congruent to triangle QOP. Now what we're going to do is, just like we did before, you might remember, we mark our givens. So first it tells us that MN is parallel to PQ. Now the way you mark that is you actually put one of these little arrows, not to be confused with a hash mark. This is an arrow, which tells me that these two lines are parallel. Okay? Now it also tells us that MO is congruent to OQ, so we'll write that as well. What we're trying to do now is mark anything else that we know. So now that I've marked this with the givens, I also know that our vertical angles are congruent, and here's where we're going to start using parallel lines. If MN is parallel to PQ, then we also know that this is the transversal. Draw it with me here, okay? See, that's a transversal. I could keep going if I wanted to, all right? Make it look a little more. And if that's the transversal of these two parallel lines, I know the alternate interior angles are congruent, all right? So if you look now, I have angle, side, angle congruence. So let's just write out our proof. All right, let's write this on out. Statement. Remember that guy? Oh, that's your old friend, reason. Remember him? And the first thing we're going to do is write our givens. MN is parallel to PQ. Okay, we're just going to write that out. That is a given. All right, and my suggestion to you is this. Try writing this out by yourself. Pause the video and do it on your own. And then just fast forward my stupid voice to see if you got it yourself. All right, maybe you did it. Maybe you're like, oh, hell yeah, I know what I'm doing. I don't need Mr. Siegel on this one, and I respect that. All right, but if not, you could just follow along with me. So I rewrote my givens. Now, let's mark what else we wrote. Angle MON, which is right here, is congruent to angle QOP. All right, and we knew that because of our friend, the vertical angle theorem. Vertical angles are congruent. All right, now 4, that's where it gets a little dicey. So we've talked about why MO is congruent to OQ. We've said why these two angles are congruent, the vertical angles, and now we mark this angle right here. We said that angle NMO is congruent to angle PQO. And why did we say that again? Oh yeah, alternate interior angles are congruent. Beautiful. And 5, now that we've discussed everything that we wrote, we can just say simply triangle MON is congruent to triangle QOP because of angle side angle congruence. Just like that, like we did back in the day. Now, just a little side note. Some of you might be saying to yourself, wait, Mr. Siegel, isn't this also a transversal of the two parallel lines? And you'd be 100% correct. You could have also marked this angle. That is totally fine. All right? You could have absolutely marked that angle and written the proof that way. But remember, you only need 3 pieces of information. And right now we have 1, 2, 3, 4. We just marked too much stuff. But if you want to do it that way, you can't do it wrong. Both of these are transversals, so they both work. All right, in this guy, now, by the way, if it looks different than what you see on your paper, please change what you see to what you see in this. But it tells us that BC is parallel to AD. So PC is parallel to AD. So we're going to put our parallel marks there, those little arrows. And it tells us that BC is congruent to AD. So I'm going to add my congruent marks. All right, doesn't matter where you put them, we'll put them right there. So there's parallel and congruent. I want to prove that DAB is congruent to triangle BCD. Well, let's continue marking our figure. We got the parallel, we got the congruent from the givens. Now you might remember we also have the reflexive property, which we can put right here. We can mark that this is the reflexive property. DB is shared on both sides, so we put that right there. Now also, because these two lines are parallel, and let's just highlight them so it's a little easier to see, DB is our transversal. And therefore, if that's the transversal, I know that these two angles right here and here would be alternate interior angles, and they're congruent. So I'm going to mark these. My alternate interior angles are congruent. All right, now I'm going to tell you this. You should be highlighting the way that I'm highlighting it. It makes it so much easier to see what the angles are if you highlight. So please, if you're having trouble identifying, what angles are formed, just take out a highlighter. Highlight the parallel lines and highlight your transversal. Now I have 3 pieces of information. It's time to write my proof. Let's go for it. We got a statement over here, and we have a reason. Let's start it off. 1, I know that BC is parallel to AD. That's a given. 2, I know that BC is congruent to AD. How do I know that? It's a given. 3, I know that BD is congruent to BD. And once again, if you can do this on your own, I suggest pausing the video and writing it yourself. But your BD is congruent to BD. That is, remember, the reflexive property. 4, let's keep going. We said that angle ADB is congruent to angle CBD. How do I know that? Alternate interior angles are congruent. And then 5, we can now say, because we've described 1, 2, 3 pieces, all the congruent pieces here, triangle DAB, oh, I know that's a dance you kids like, is congruent to triangle BCD because of, well, what kind of do we have? Side angle side. Side angle side congruence. Beautiful. Now that is a beautiful proof. Nice job, me. No problem, me. All right. Let's keep on moving. We got 2 more proofs we're going to do. Just 2 more. All right. And hopefully you should get the hang of it. Now this is one of the more difficult proofs. All right. It's going to get a little bit harder than it's been. So let's write our givens, and then we'll see how we're going to prove AB is congruent to DC. Now you might remember when you're trying to prove that 2 things are congruent, all right, because it's not asking to prove the triangles are congruent. It's saying I want to prove that AB is congruent to DC. First, don't mark this. You might remember me saying this in class last time. That's what you're trying to prove. And 2, we're going to use CPCTC to mark that. Remember, that's congruent parts of corresponding parts of congruent triangles is congruent. All right. First, we prove the triangles are congruent. Then we'll use CPCTC. All right, enough talk. Let's get into it. It's game time. So first, we know that AC is parallel with DE. Okay, that's number 1. 2, I know C is the midpoint of BE. If C is the midpoint, then I know BC is congruent to CE. Remember, the midpoint cuts a line in half. All right, and then finally, I also know that AC is congruent to DE. We'll mark that as well, just like that. Look how beautiful that is. All right, now let's get in. Now, if you notice here, we only have 2 pieces of congruent information. We need 1 more congruent things. And like I said before, this is kind of hard to visualize. Like, what the hell? Why does this even help us? All right, and I will show you how. You're going to highlight your 2 parallel lines. So it tells us that AC is parallel with DE. And let's highlight the transversal. What's the line intersecting both of them? And that's this line right here. All right, that's our transversal. Now, how does this help us? All right, what angles can we say is true? We don't have alternate interior this time, right? That's like over here. So we don't have alternate interior. What we do have, if you look over here, is corresponding angles. You see? Corresponding angle, if this is the transversal, then these are the corresponding angles. Tough to see there, but that's why the highlighter helps. And now we have side angle side congruence. So let's write out a proof. All right, statement, reason. Now, I know I keep saying this, and you probably get the point now, but try writing it first, then looking at the video and see if you did it correctly. 1, AC is parallel to DE. Dope. Bup, bup. That is givo. 2, C is the midpoint of BE. All right, and 2, we'll say given. 3, AC is congruent to DE. All right, and that is given. And now we got to start explaining the rest of the stuff we marked. So we only said 1 thing that's congruent. All right, we said that AC is congruent to DE. Let's move on to this part. We also said that BC was congruent to CE. All right, and why did we say that again? Well, I'll remember. If you remember this statement about midpoints, a midpoint divides a line in two congruent parts. Sweet. 5. What else haven't we talked about? This angle. So we're going to say angle BCA is congruent to angle DCE because of corresponding angles are congruent. All right. We're doing pretty good right now. Now we've described all three things, so we're going to say 6, triangle ABC is congruent to triangle DCE because of side angle side congruence. And now finally we have to write our conclusion, because remember, it's not asking us to prove the triangle is congruent, it's trying to tell us to prove AB is congruent to DC. And how do I know AB is congruent to DC? AB is congruent to DC. Well, you might remember that we say that that is CPCTC. If these two triangles are congruent, then I could also state that all the corresponding parts are congruent. So DC must be congruent to AB if those are congruent. And that's how you write this proof. Biggity bam, we're done. All right, we got one more to write. And this one's a little different. You'll notice sometimes we're going to prove that two triangles are similar. Ooh, throwing in some level 3 stuff here. Pretty dope, huh? And our only given in this case is that DE is parallel to AC. All right, and we're trying to prove that these are similar. Now, first I just want to remind you, there's 3 ways to prove similarity. Angle, angle, side, side, and SSS. All right, we're going to try to use one of these. So, here's what we know. We know that if these two lines are parallel, all right, then this is a transversal, and if that's a transversal, the corresponding angles are congruent. These are my corresponding angles. You see how that works? So I know this angle is congruent this way, if these two lines are parallel. We can also mark on the other side, right? We could also do that over here. We could say that these two corresponding angles are congruent. And that's why if these two lines are parallel, you get two similar triangles, because these corresponding angles are congruent. I was actually surprised. All of last unit, I kept saying these lines need to be parallel for them to be similar. No one even asked me why. This is why. Because you have angle-angle similarity. In fact, you could even say that angle B is congruent to angle B because of the reflexive property, but why overboard it? We only need 2 angles for angle-angle similarity. So we've proved similarity by proving that there's two congruent angles in these two triangles. So let's go for it. We have a statement and we have a reason. Okay? So 1, we'll write out our givens. DE is parallel to AC. All right? That's a given. 2, I know that angle BDE is congruent to angle BAC. How did I know that? Because corresponding angles are congruent. That says R angle, duh. 3, I also know that angle BED is congruent to angle BCA. That's also because corresponding angles are congruent. And unlike with with congruence proofs, I only need to prove that 2 angles are congruent here. So I've actually finished my proof. All I have to now say is that triangle ABC is similar to triangle DBE because of, remember, we used angle-angle similarity. Boom! That's it for this lesson. So remember, that's all you need to know for proofs. Review this. You can watch this video as many times as you want until this sets in, and then you will get how to do these proofs. Now, another thing is this. As my daily piece of advice for you, I just want you to know this. Don't kiss a squirrel. It might give you rabies. I know they're cute and you want to cuddle it, but you can't because they're gross. Bye.